before we actually get into the math stuff. So just a few reminders, I've got them written down here. So first of all, there is a practice assignment online. It's just for practice, of course. I'll share my screen. It's just practice, which means you don't need to actually do it if you don't want to. But the reason I put it up there was to make sure you know how to use the Dropbox. So I've already got one submission here from Sarah, so thank you, Sarah. If you don't do this assignment, then when the assignment comes up on Sunday, which is actually a math assignment, if you have trouble submitting that or scanning your work or anything like that, too bad. Because if you have the issues, this is the whole point of the practice assignment, is to practice, get all those issues out of the way, and then you...
Are we gonna upload it in the Dropbox?
Yeah.
Okay.
So what I'd like you to do is you go to Assessments in Dropbox, and then you'll just see, you know, the practice assignment here. It's like, it takes 2 minutes. It's just a couple questions about just personal questions. Just, you know, have you done math before? What's your favorite TV show? Stuff like that. But I want to make sure you can download it, print it, or at least have a notepad that you write out the answers on, and then scan that back. Or if you want to write on the PDF itself, you can, but just get that assignment back. Because on Sunday, this is how it's going to work. You're going to have a 30-minute assignment at the end of class, okay? So if we have a 9 o'clock class, it's going to start at 10. I don't think we have a 9 o'clock class on Sunday. Anyway, it doesn't matter. 30 minutes at the end of class, you go into the Dropbox, you get the assignment, you work on the assignment. Within half an hour, 45 minutes, I need that assignment back in the Dropbox. If you don't know how to put it back in the Dropbox, you don't get the marks for the assignment. So that's the whole point of this practice. I'm giving you a chance to make sure you know how to do it, okay? So hopefully that is helpful, and if you choose not to do it, then it's your responsibility, okay? So that's the first thing. Second thing is assignment 1 is Sunday, as I just mentioned. It's 3 questions. It's 1 page, just it'll literally just be 1 page. With 3 questions on it, and it covers all of Unit 1. Well, it's not every question, of course, but it's just any 3 questions from somewhere in Unit 1, okay? So if you've done all the practice by Sunday, you should have no trouble, all right? Or you should only have a little trouble. It'll be worth, it'll have workings though, of course, so I'll just give you part marks for anything that you do correctly. Other than that, just some basic items. Obviously, keep checking D2L. I update it every day, try and make it as clear as possible. You should have read this before today, but if you're not reading it, please do. And the YouTube playlists. So it says here, bookmark the YouTube playlists. I've actually got 3 playlists now, but really all you should care about is 2 of them. Math lessons, the videos that Tom made, are all there. And also, let me see if I can go track it down. Yeah. On my YouTube page, this is just a version of one of the YouTube accounts that I have. Under playlists, you can find your own class. So for example, this is 1101-3. That's your section. You can check this playlist. You know, you can just subscribe to it. Bookmark the page or subscribe to the YouTube channel, and then you have all of our classes in one place. Hey, it's me. Or you can just go to the Zoom tab. I don't care how you get to the classes. What I care about is that you watch them if you've missed them. Okay. Other than that, speaking of the lessons, you are responsible for watching these video lessons. Like, those video lessons are the first time you should see the material. I should be giving you the second look at the material, where I kind of break it down, summarize it where I can, and then do a few extra practice problems. So if you're not watching those videos, Tom's videos, you're kind of missing half the course, because he goes into more detail introducing the topics, okay? I'm kind of here to fill in the gaps where I can and take your questions live, all right? So hopefully that's clear. And some of you, I'm probably boring you to death because I've already told you this, but I'm making sure that everyone knows that this is what you're supposed to be doing, okay? Final thing before we start, I will be posting full solutions online sometime today. Now, I've already posted my handwritten solutions. So if you go into content, And I think I put it under class notes. Yeah, it says Unit 1, Mr. Scott's handwritten notes. So I'll update this every few days, but anything that I write in class, I'm going to put in this document. So you can see, you can download this, or probably you don't need to download it. You can get it on your phone. Anyway, everything that I write is here, as you can see. All right. And in addition to that, I'm going to give you full solutions that have every example and every practice problem done. All right. So then before your assignments, before your tests, you have any practice problem you could want worked out so that you can work through it again. Is that clear?
Yes.
Yes.
Okay. I'm already tired. Can we go to sleep again? Can I just take a little nap here? Okay. All right. Let's get started if there's nothing pressing, if there's nothing else that you want to bring up. So at any time, interrupt me. It doesn't bother me. What we've covered so far is this in class 1. In the second class, we did some polar form stuff. That was yesterday. Today, we're going to do exponential form, which is basically just an extension of polar form. Literally, there's only one difference. We covered it yesterday. The only difference is we changed the degrees to radians. Everything else is the same. So we're going to do that today, exponential form. De Moivre's theorem, it's a French guy. De Moivre's theorem is a way of working with polar form when you have powers. But it's actually really easy. So of all the 3 classes, I would say that today I expect will probably be the easiest class. And if everything goes well, we'll actually finish early. But I'm not going to promise that because I have a tendency not to go early because I talk too much. I get too excited. Okay, so let's quickly summarize what I did yesterday, the last thing I did yesterday. We covered polar form, which is up here on the top, polar form, which is our angle theta. The point I made here was that that angle is always in degrees. And so just in case you missed the big idea here, if you had some vector or some complex number that was over here, that angle needs to come from the positive x-axis, always. So for example, if you're given, I don't know, maybe on your assignment, hint, hint, nudge, nudge, if you were given this vector and it gave you an angle, for example, 30, you would have, before you started anything, you would need to tell me what the actual angle is in polar form. So you would have to look at this and say, all right, this is actually the angle we care about here, which is 360 minus 30. So it would actually be 330 degrees, okay? So the angle we're talking about, no matter if it's in degrees or radians, is always from that positive x-axis, and then however much it's turned upward and around, that is the angle that always goes into that form. All right, so moving on from polar form, the last thing we did is exponential form. The only difference, besides it looks a little different, but whatever, is the angle. So just change it to radians first, and everything else is more or less the same. So I'll do this second example, and we'll go straight into the practice. This example was done on the video, but I'll do it from scratch, okay? So first things first, what form is this in right now? I'm talking about B. What form is this? Hmm? Sorry, I didn't hear you.
Exponential form.
Exponential, yeah. This is already an exponential form. And so what it's asking us to do is go from exponential to rectangular and polar. So it's very easy to go from exponential to polar. I mean, exponential and polar are basically like brothers, okay? They're connected. They're almost the same thing. So it makes sense to go to polar first and then go to rectangular because it's more work to go to rectangular. So all you need to do, let me get my color set up here. We know that the angle here is given. The angle is 1.85. That is degrees, sorry, that is radians right now. So that's radians. How do I convert radians to degrees? It's a very simple multiplication.
Multiply by over 180.
Careful. If you multiply, yeah, if you multiply by pi on top, it will not cancel the radians. I is a way of saying radians, okay? So radians and pi are the same units. That's how they cancel. And then the 180 degrees is what turns it into degrees. So really what we have here is whatever 1.85 times 180 is, which is 333 degrees. All right, that's pretty simple. Let me get the other example so we can compare it. Polar form, all we need to do, we already have R, it's 464. So polar form, 464, angle 333 degrees. Halas, we're finished, okay? This is polar form. Polar. I'm not going to do the full calculation for rectangular. I'm just going to do what we did yesterday, which is R cos theta, R sine theta. When you multiply those out, I've got it done here somewhere. I'll just quickly jump to the answer. What I got when I did this was negative 128 plus 446J. And we know it's rectangular form because it has an A piece in the beginning. This is A, and a B piece that's attached to the J, the imaginary part. This is rectangular. And we're finished. So conversions are not long. All you need to do is change the angle. Everything else is what we did before. Cool? I mean, it might not be cool. It's not cool in the way that like James Bond is cool or something like that, but at least for math, it's easy, which I think is cool. All right, I'll do one more, and then I want you to try B. So I'll show you how fast I do this. Right away, I'm given 3.84, that's in radians. So I need to go ahead and change it to degrees. Sorry, it's in radians, yeah. So I have pi on bottom to cancel it, and then our 180 on top. That gives me, let's see, 220. You should always check my calculations. I said this yesterday, I think. I have a tendency to make small mistakes, sometimes on purpose, sometimes not. Online,
Good morning, sir.
not to do too many mistakes. What'd you say?
Good morning, sir.
Good morning, Jassim. How are you doing?
I'm fine, thank you, sir. I am working very hard on the problems and solutions.
Okay.
Yeah, and I want to be ready for the assignment on Sunday.
Good.
Okay.
I'm happy.
Thank you.
So
sir. Thank
now
you.
we've changed our radians. Now I'll make a little note. This was a radian, and this is of course degrees. So the radians cancel in the beginning, it makes it degrees, we're all okay. So polar form can be written directly, 2.50, angle 220. Once again, that's our polar form. Rectangular form, 2.5 cos 220, which comes out, I think, to negative 1.92. And then the other one is negative 1.61 J. Once again, this is our A, and this is our B, so we know that it's in rectangular form, okay? Two things, polar, rectangular. They're very fast. Any questions on that? Is that a no?
No, sir.
Okay, try B. Take 30 seconds and try question B. Thanks, Sarah. I'm not sure about the angle. Oh yeah, no, I think it might be okay. Let me see. Your angle doesn't look right, Sarah. So that's been 30 seconds. I'm glad you tried it. Let me double check it with you. So first of all, yeah, 172. Sorry, I'm just trying to resize my chat here. I don't know if, from the teacher side, when I'm sharing my screen, I have to get out of things to get into the chat. So every now and then I'm like, I just give up. but I try to get to your numbers. So yeah, 0.8 is definitely R. Let me get my 3 changed. So this is 3 radians. Multiply it by 180 degrees over pi. I guess the degrees should have been back over here. That'll cancel it. For me, I got 171.9 or 172. This is degrees. Okay, I'm so happy to see some answers coming in here. That's exactly what I want. I want everyone trying this stuff as you go, right? So polar form, 0.800, just copy the R, and then angle, 171.9. Sarah, how did you get 45.9? I'm not trying to put you on the spot, but did you just make a calculation error? Because it's possible another student will do your same mistake. That's what I'm asking. Okay, yeah, 0.8 instead of the angle. Okay, no problem. Yeah, silly mistakes like that happen all the time. I was like the king of silly mistakes. I still am in a lot of cases. But definitely as a student, I almost never got 100 on a test. It would always be, I'd be the student who gets 98 because I forgot a decimal or I forgot this number or that number, whatever. It's not the end of the world. So this is polar form, this is rectangular form. I'm seeing a lot of the right answers here. So if you got the right answer, you know, go ahead and pat yourself on the back. I can't do that for you because it's COVID time and, you know, don't touch your face, don't touch each other. Sort of thing. Okay, so good job, we got through that. If you don't have any questions, we'll just go ahead and move on to the next one. These next examples are just doing the same thing, but we're converting to exponential form. All of these examples are done in the video, so I'm just gonna do the practice. For example, we're given polar form already. We wanna change it to exponential form. And remember, the only difference here is theta. You know, the only difference. For polar form, it's in degrees. For exponential form, it's in radians. So currently, in polar form, it's in degrees, so we just need to change that. This is 68 degrees. You can see it's degrees because of the symbol. Don't get confused as to what the fraction is. You don't even really need to memorize it. You just need to remember, you have to cancel degrees. And so we put the 180 degrees on bottom instead of pi on bottom. That will make sure that these things cancel. The degree will cancel, and we'll get radians out of this. That's because pi is on top, and pi is a version of saying radians. What we get out of this, I'll just check and see what I had for this, I think is 1.19, and I always write radians here, try to remember because it's easy to get confused. That's all we need to do. We already had R. If you don't know why, it's because it comes from here. R was the same. And now what is exponential form? We have an E, and then I think we had a J and a theta on top. I'm gonna write the theta first because usually we like the letter at the end, just like X's. So this is my answer. Did anyone try that themselves and see if they get the same thing?
Yes, it's the same.
Same? Okay, I always like at least one person to check it because once again, I'm a human like everybody else. I just tippy-tap on my calculator and see what pops out. So try B, you know, take 30 seconds. That's all that these should take and figure out the answer to B. All right, so I'll give you till 9:24. right, we're back. That was 30 seconds, give or take a few seconds. Right away, I look at this question and I see degrees. Okay, it's in two places, but whatever, they're both theta. So our theta or our angle is 245 degrees currently. I've got to change it to radians because that's how exponential works. 4.3, yeah, I'm gonna keep 4.28 just for a little more precision, but it's okay. 4.3 I would totally accept. A lot of students get stressed out over if I'm gonna take off marks for rounding, and I'm not. As long as you're, you know, in the right ballpark, so they say. I don't know how many baseball fans we have. If you're in the right gym, if you got basically the right answer, that's all I really care about. So I'm gonna say 4.28. You can leave it like that because radians are sort of unitless, or you can write radians on it. I like to write radians, so you remember. And now what were we looking for? We want an exponential form. So 15.3 e to the power of 4.28, and don't forget the j. That's our final answer. Not bad. Any questions on that?
No, all good.
Take that deathly silence as a no. Okay, so for C, you'll notice that in C here, well, you should notice that in C, this is currently in rectangular form. And so in order to get it to exponential form, we need to work with, of course, what we've been given. So normally when we have rectangular form, what are the two things we need to find? There's two things we always need to find in order to change it to polar form.
Angle and the polar form.
Angle and R. Right?
R.
So you can always draw a little sketch. Remember, this is telling us that it's to the right and down. So we need two things to describe this. We have R, but we also need the angle. We need to know how big this vector is, and then how far away from x it is from the positive axis. Two things fully describe it in polar form. So R is a squared plus b squared, square rooted. We did that before, so I'm just going to take these numbers, 6 point, I probably don't need to show this, but just for any of you that maybe want to insight into how I would do it, I would just take the numbers without the negatives, put them under the sign, add them up, square it. You don't need to worry about the negatives because you're going to square it anyways. So save yourself some time, forget about the negatives, and I get 7.53. Right. Sorry, it's a little ugly. I experimented with drawing it without putting it on the table and it failed. So that's R. Theta, we remember what we need to do. I hope. Got two pieces. I don't need to highlight that. We're going to take A and B. We're going to take inverse tan of B over A. So inverse tan, always B over A. So I'll write the number. You take the positive, divided by your A value, 6.81. Now the angle we get out of this, we're not going to be able to trust. You remember that? Do you know what it's called? The angle that this gives us? Do you know what the name of that angle is? Anybody? Has a special name. It's clearly not the right angle. It's not the correct angle because it's at least 90, 180, 270. It should be somewhere between 270 and 360. It's called the reference angle. So we need to figure out how far it is away from X. Which quadrant is this in currently? 1, 2, 3, or 4?
Fourth.
In the fourth quadrant, yeah. So hitch on these, that looks like the right answer to me. So it looks like you're on the right track. When we do quadrant 4, our rule is theta must be 360 minus that angle that pops out of your calculator, called the reference angle. That's why I draw that little fish-looking thing. That's alpha, and that's the angle that your calculator is actually giving you. So we'll just say the angle is actually 360 minus 25.3, or what Hisham said was 334.7, which is exactly right. That's our actual angle. Of course, this does not take as long as I'm making it take. I'm taking all this time to make sure you understand. When you understand this yourself, you should be able to get this done in just 10 seconds, 15 seconds maybe, give or take. So where am I? I'm trying to get exponential form, yeah? So I have enough information now. Oh, no, I don't. What do I need to do? I need to change my degrees into radians. So it's really 3 steps. 334.7 degrees. In order to get rid of degrees, I have to cancel them on bottom, and pi hangs out on top. That'll cancel these guys and leave my radians. So that should be, I think, 5.84 is what I got. Now it's fully described. 7.53 E 5.84 J. And just in case you got lost, the R, of course. I don't know how I feel about that color yellow, but I'm gonna just own it. It's probably my least favorite of all the colors, but that's where it came from. R and theta. Is that okay?
Yeah.
All good? Good enough for a Thursday? You probably can guess what I'm gonna ask you to do now. What am I gonna ask you to do?
Solve one D.
Try D, please. You should be able to do it in about 1 minute. I'll give you maybe 2 minutes if you really need it. I'll give you a hand and I'll draw the sketch first. You're gonna need that. Sorry, I didn't realize you could see all the little diddly bits I do here. I'm just, when students are watching these recordings back, I realize maybe it's better I pause the breaks so that the overall video is shorter. Oh, before I forget, I have my audio on here. Okay, before I forget, when I put these up onto YouTube, right now they have no description. You know, when you look at a YouTube video, you've got the main video and you've got the description below it. What I normally do when I post videos is in the description, I put timestamps. So for example, it'll be like example 1, example 2, example 3, and you click all those times and it'll jump right to that point in the video. I didn't do it this time because I don't have enough time right now, but I'm hoping over the weekend that I'll have time to go through the videos again and put all the timestamps in, which means, for example, you're like, okay, well, in class on Tuesday, he did this example, and I don't remember it. I'd like to watch it again, but you don't want to scroll through the entire video again to go find it. So you can go in the description and go, oh, example D, and click that, all right? So that's my plan. I'm not promising anything because I do have a 2-year-old and it is a weekend and blah, 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 but I'll try to get that done for you because when you're studying for your assignments and tests, I think that would help. Okay, so yes, the answers coming in look right. My final answer is 12.2 e to the power of 2.32j. And the way I got this was the exact same way I always get this. A squared plus b squared, square rooted, is 12.2. You don't need to show work for that as long as you know how to get that. Your angle here, if you do the same thing, tan of, inverse tan of 9 over 8.3, you get 47.3. Now we need to change that. Notice this is in quadrant 2. If it's in quadrant 2, it's 180 minus the reference angle. The reason for that is because your calculator is trying to give you this tiny little piece, always the acute part, and we want, of course, we want this part. So it's the whole half turn subtracted the little piece must be what's remaining. Anyway, so it's 180 minus 47.3. And that gives us the actual angle, which is 132.7. When you convert that, you know, 132.7 degrees times pi over 180 degrees should give us 2.32 radians, or close to it within a decimal place or so. Now we have r, we have theta, and so we have exponential form. And in fact, if I had asked for polar form, you would have that too. J. Okay, so these are our final answers here. Anything I can review there before we move on? We've got a few more topics to do today. Going once, going twice. Don't forget that the quickest way to answer things, you could always go into participants and click the thumbs up, thumbs down, blah, 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 blah. There's lots of controls there for if you want to just give me a quick answer without typing, okay? So let's move on. Now, what have we covered so far? We wrote complex numbers in exponential form. We did this, that's done. We converted complex numbers from exponential form to both polar and rectangular, and vice versa, which means backwards, both ways. This, I don't know if this action is helping, but one way and then the other way. And now we need to, oh, you can't see this, sorry, my bad. Whoa, gone rogue. Okay, my eraser's not working. Multiply and divide complex numbers in exponential form. Well, we already multiplied and divided complex numbers in polar form, and you'll see it's exactly the same. So you kind of already know how to do it. And then we're going to find the powers and roots of complex numbers. Okay, so let's go ahead and do that. Sorry, I'm trying something new here. It's not necessarily working. Okay, multiply and divide complex numbers in exponential form. What it's saying is we multiply the r's. This is not new. And we add the angles. Also not new. We did that with polar form, if you remember. When it's division, we subtract the angles and we divide the r's. It is the exact same thing as polar form. In fact, the reason it works in polar form is because of exponential form. You can even see it more clearly here. Look, r1 divided by r2 is of course r1 over r2, all right? But then we have e, let me write this to the side. If you have e to e theta 1j divided by e theta 2j, just look at these thetas. Those are the only things that are different here. We have a common factor. And so what happens is you use your exponential rules or your exponent rules. It's the top one minus the bottom one, yeah? Divided gives subtraction. Let me give you an example. If you add x to the power of 3 divided by x to the power of 2, that would of course be the same as x 3 minus 2. So when you divide things, you get a subtraction with the powers. That's why this rule works. You don't need to remember why the rule works, but you do need to remember the rule, or at least have this table somewhere nearby. Okay, so that's just a little insight into why it works. Same thing for multiply. Let's go ahead and actually do an example before I bore you to death. Perform the indicated operation. What is the indicated operation? Well, in A here, this is a multiply, which means that your r's are going to multiply and your thetas are going to add. Let's just do it. What's 0.4 times 1.2? 0.4 times 1.2 is 12 over 15 apparently, or 0.48. I'm going to keep my e. The radians on top, the angles, they just add. And so you could probably do it in your head if you're good enough, but just add them together, you get 1.74. J. Done. If you're not sure where that came from, let me just break it down for you. We have 0.4 times 1.2 is where that r came from. This theta is 0.66 plus 1.08. That's, that's where the theta came from. And this is where the r came from. We've already done it, but does that make sense?
Yes.
Okay. I can always count on Nasser. I think everyone else is just waiting for Nasser to say something. Nasser or Noran or something, yeah. But it's okay. Try B. you know, take 30 seconds. It shouldn't even, I don't even think it'll take 30 seconds. Take 10 seconds and do B. Tell me what you get. I want to make sure that you're all awake or conscious. You know, I want your mind to be on.
$60 and 3109.
Okay, yes, correct. That's it. You don't need to show any work because it's so fast, all right? That's all you need to do. You don't need to do anything fancy, just multiply and then add. So the division works the exact same way. And the only person, well, I guess Nasser replied and Aisha also replied. You were both right. Congratulations. Actually, Aisha, you forgot the J. So don't forget that you need to put the little tiny J in there as well because it is still a complex number. You can probably guess where I'm going with this. The division is exactly the same. It's 3.22. I'm just looking at C here. It's 3.22 divided by, let me get my notes up so that I don't need to do all the calculations. I'm getting, I should have put the equal signs here. 3.22 divided by 1.56, I'm getting 2.06. And then the exponents, of course, use your exponents rules where you subtract. It's 0.64. So once again, I'll write this. For division, if it's division, your R's divide, by your thetas subtract. That's all there is to it. I'm not going to waste time by asking you to do D. You can do it with me. And hopefully you understand how to do it. So I'm going to do 2.85 divided by 5.68. For me, I get 0.5017, so 502. Just take as many decimal places as you feel describes the number well enough. Usually, if it starts with a 0, 3 decimal places is pretty standard. And then E, and what do I do with these? I don't divide them, I subtract them. So that's 0.65 with a J. And so this is, these are the final answers for this type of question. And that's basically it. I think that's pretty much the whole section. Pretty clear?
Yes.
Okay, thank you. I'm not trying to be awkward, all right? I'm generally not an awkward guy, but I think I said this yesterday. You might not realize how difficult it is to be on this side. It's one thing to be the student and you can just sit back and, you know, you just check in every now and then when you feel like it and move away. I have to be on constantly. And so I'm still standing here in an empty into the void. It's nice when I say that I see that the void can talk back. You know what I mean? So if there's nothing else, we'll move right on. So I think that was, yeah, multiplying and dividing. That was a whole topic in itself that we just covered. This is the final real topic, and it looks kind of intimidating, but it's not. All it is, de Moivre's theorem, it's a French guy, like I said, really boils down to this. If you have something in polar form, exponential form too, I guess, but mainly polar form, it's dealing with powers. So you'll notice, let me try to make this as clear as I can. If you have a number, let's just say you had a 5 and the angle was 45. So we have a polar form number, r is 5, theta is 45, but then we took this number and put it to the power of something, which we have not done before. If you'll notice, we did addition, subtraction, multiplication, and division. We haven't done the power thankfully, this de Moivre guy came in, and it was like hundreds of years ago, and he was like, hey, I've figured out a way to do this. It's very, very simple. You take the R gets the power. As normal, it's like R does what you expect it to do, and the angles always do one thing less. So if the R's do the regular thing, then instead of the angles getting the powers, they're gonna just multiply. So it looks like this, 4 times 45. So let me color code this. This 4, let's just say it's the blue guy, it goes onto the R as normal, but it comes down and it'll just multiply the angle, okay? So we always have kind of like a little change for the angles, one simpler operation. And then we just multiply that out. So what is 5 to the power of 4? Again, this is just a random example off the top of my head, but 5 to the power of 4 is 625. Our angle here, 4 times 45, that's 180. And so that's what de Moivre gives us. He allows us to do powers really fast. Honestly, it's just as easy as multiplication and division. That's about it. So let's do, the examples are already done in the videos, so I want to skip those, but I will do some practice. Now, right away in practice 14a, we don't have polar form. So de Moivre's theorem doesn't work unless we're in polar form already. So this is rectangular form. We need polar form. And so we change it to polar form first. How do I change a rectangular number to polar form? Well, we just did that. We need 2 things. We always need 2 things. You need R, and you also need theta. I'm going to draw a little sketch just in case I need it. This is still over 4 down 3, so it's going to look like this. What's R? If you're good with your triangles, you can do it in your head. It's 5. The angle here is, let's see, tan inverse. I'll write it out because some of you still need a little extra support with this. This is 3 over 4. Tan of 3 over 4 is 36.9 degrees, but it's in quadrant 4. For quadrant 4, we take 360 minus. 360 minus that 36.9, which is 320, I think 323.1. Can someone confirm that?
Yes, it's right.
Okay. So now I have both things. I have R, I have theta. Now, of course, that was not the question. The question was to get the power of 4 of all this stuff, but we'll get to that. I'm going to write out my polar form, 323.1, and then I'm going to go back and I'll just put back in my powers, okay? So I put my powers on top. That's because that came from the beginning. I can't forget what I was trying to do in the first place. So just a quick recap. The question asked me to get the power of 4 of this thing. It's in rectangular form. I don't need rectangular form. I need polar form. So change it to polar form first and then get the power. And de Moivre's theorem states that this is the same as 5 to the power of 4 and then 4 times whatever angle is inside here. Which is, let's see, 5 to the power of 4. Well, I actually just did that, it's 625. And the angle is what? What's 4 times 323.1? Whoa, 1292.4. I'm going to rearrange this just a little bit because I need a bit of space. Oh no, you can't do this if you have if you're working on paper, but you can use a notebook maybe. This is a problem. Why is this a problem? Anybody? What's the problem with this? Yeah. So Aisha said it's a big number for the angle, and to be specific, it's way bigger than 360. Now, if you look at a circle, you know, a circle works like this. We have 360 degrees. That's one turn. A second turn, we go 720 and then 1080. And then we got to go even bigger. We go all the way around until, okay, I think my pen just did something weird. My computer just is freaking out. Okay, we got to keep going around and around and around to get to where this same angle is, okay? So what I'm trying to say is you should only go around up to 360. Everything after that is exactly the same. You're just wasting your time. So long story short, keep taking away 360 until you're between 0 and 360. Yeah, so Aisha said minus 360. Yeah, do that again and again and again. Minus 360 as many times as you need to get to a smaller number. So if I subtract 360 once, I get 932.4. If I subtract 360 again, I get 572.4. And if I get 360 again, it becomes 212.4. That final 212.4, that's what I'm looking for. So this is something you can just do on your calculator. You don't need to do it every time. So my final answer, 4 minus 3j to the power 4 is equal to 625, giant radius, but it is what it is, 212.4 degrees. That's my final answer. Again, sometimes this seems like a lot of work. It's really not quite as long as it looks. I just take a long time to explain it the first few times. I want to give you another tip when you're doing calculations. That's my previous one. Let's just say you had this angle 1292.4, all right? 1292.4. Some students already do this, but whatever. Take away 360. Oops, I don't know what that stuff was. Take away 360 and we end up, I think I'm right clicking, sorry. We end up with this. We end up with 932.4. That's too big. So you don't need to type the whole thing in again. Just hit the subtract button. It'll take the last answer. Subtract 360 again. Now we get a new answer. Still too big. It's bigger than 360. We got to keep going. Minus 360. Now this is the answer I'm looking for. You know it's the right answer because it's between 0 and 360. If you go too far, if you do this too many times, you're going to get a negative and you're going to be like, ugh, okay, that's not so good. You're going to add it back on, just add 360 back on to get where you want to be. Got it? So I want you to try B. B is basically, hi Abdullah. B is essentially the same thing. I'd like you to give that a try. You should be able to do it in about a minute or 2 minutes. So I'm going to give you until 9:55 to get this done. It's 9:55. Do we need more time? Did anyone fall asleep? Am I bored?
Hi, good morning, sir.
Hi, Abdullah.
Actually, I wake up at 8:50. I say just 10 minutes and I sleep for 1 hour.
It's okay. This is all recorded. You can catch up later if you need to.
Good morning, Abdallah.
Does anyone have an answer? Or did I
the
lose
hour
everybody?
is,
What's up?
the hour it's in B 7.2.
The R will be, I've got root 53, which is, yeah, 7.28.
Yep.
I'm just gonna write root 53. Is anyone else alive out there? I feel like maybe I talked for too long and students have just disappeared into the ether.
And it's 164, I think.
That is definitely the right size. So 180 minus our angle. I've got 105.9.
Yeah, it's 105.
So that's what I get. And now it's polar form, which is good. I can write out my full thing. So root 53, angle 105.9, and our power of 3 from the beginning. So root 53 to the power of 3. I will probably write it as a decimal. It's just a little bit easier now. Is this guy?
It's same. 3 point. Okay.
This is what I get. Now, if you haven't tried it yourself, it probably doesn't mean a whole lot. But if you did try it, then hopefully you can confirm your answer. Okay. Can't tell if it's good or not, but I'm going to move on anyways. So
Good.
same idea here. We've got rectangular form, a different version of polar form given, which is really helpful. We don't need to change anything first. So these are going to be really fast. In fact, C and D and E and F are all going to be fast because we're already given R and we're already given theta. So just let's try this. 3 to the power of 4 is 81. Cosine 100, well, we take the 100, multiply it by 4. It's 400. Same rules as before. We do the regular power on the, regular power on the R's, and theta times 4 on the thetas. And that's pretty much it. There's nothing really left to do except for we should not be happy with these. Just take away 360. So that's going to be 40. Okay, so hopefully that makes a bit of sense. Again, it was already given in polar form, so there's very little to do. You just use de Moivre's theorem and pop out an answer. So I'd like you to take 30 seconds and try D, and then E and F are just essentially tiny little questions. We don't even really need to do them, okay? So try D. I'd like everyone to try it, everyone who's still paying attention. Yes. That's exactly right. Well, it's exactly what I got, assuming that I'm right. So 8 to the power of 5, we go ahead and put that in, and we get 3, 2, 7, 6, 8. I'm going to keep the form that it gave me. 80, this is 80 times 5, which gives 400. Once again, that's too big. It's bigger than 360. That's a bad thing. Just take away 360 until you get something smaller. By doing that, we should get angle 40, which is exactly what you said. And using the shorter form is, of course, nicer. You're always allowed to use that unless it asks for a specific version of the form, okay? So either of these are fine. If you want to save yourself time, go ahead and use the second one. If you want to fully understand where every single piece comes from, make it easy to convert back to rectangular form, you can use the first one. But they're the same. E and F, I really don't think, unless you want me to do more practice, I can do E and F, but who would like me to move on to the last topic? The deadly silence.
What?
Who's in my room? I'm just going to move on. I was just asking if you wanted me to do the E and F, but I'll leave it as an exercise. Once again, I'm putting these solutions online anyways, so if you need it, you can get it. So it's the same idea.
صار بالي.
Yeah.
It's 125 and 5.
Okay, so I'd like to do the last topic. This is the last topic in the whole unit, and I have a feeling we might end early depending on how this goes, which for a Thursday, that might be nice for a break. By the way, the reason I look over here all the time is because I have a second monitor and I just keep track of everything. So let's do this. Someone was very sick of me. So in this topic, this last topic, we're going to find what's called fractional values of complex numbers. And these are just called roots. It's essentially, it's kind of like finding our x values when we had functions, you know, the roots of a function. What I mean is if you had, you know, you have this basic function, it's kind of like finding the x values like this, but for complex numbers, it's finding points on a circle. But essentially, we just need to follow a process. We don't need to get too deep into this. So there's a 4-step process. First thing we're going to do is express whatever we're given in polar form, if it's not already. Then we need to give a fractional root, which means if we had, for example, x cubed, that becomes x to the power of 1 over 3. That's all that means. Instead of having a, wait, no. If it was root 3, cube root, it becomes power 1 over 3. That's what it means by fractional form. You can see, of course, there's a fraction there. Third step is to use de Moivre's theorem to find a root, which is what we just did. And then we're going to keep adding 360 until we get all the roots we want. So let me just go ahead and show you what I mean. I'll do the first example here. It says find all square roots of 2j. What I've said here is that this number, it's the same as being asked, what are the square roots? Oops, no, I'll just leave what I had before. It was already there. It's saying, technically it's, you don't need to, I don't know why I'm confusing myself. I just had like a total lapse of brain power. We're trying to figure out what values pop out of a square root of 2j. So square root, you need to know that that means your basic square root, which is the same as something to the power of 1 over 2. Let's just show you what I mean. So we need to express the number in polar form. 2j in polar form, well, it looks like this. So our number should be 2 angle 90. Sorry if I lost anyone there. I just had, I don't know, my brain just completely collapsed in on itself. So that's our first step. We needed to put it in polar form. We're done. The second step is to express the root in fractional form. So again, we're getting the square root, which means we want it to the power of 1/2. It's the square root, so we use power of 1/2. That's our second step. Our third step is to use de Moivre's theorem with theta to find the root. So just do what we did before. What is 2 to the power of 1/2? Well, it's root 2. And then we need to get, we need to get the angle as well. So what's 1/2 of 90? Oops, it's 45. Now, we're not done. We do have, of course, that's what we would call one root. That's the first root. But we need to go further and figure out what all the roots are. And let me just see. I think we need to convert all these into rectangular form as well. Yeah, we do. So let me just reorganize this so that I want to make it a little more clear to you. This as rectangular form is what? Do you remember how to convert to rectangular form? If you don't, you need to do this.
Use cosine and sine.
Yeah. So we take root 2 and we multiply it by cosine of 45. That gives us a 1. And we take root 2, multiply it by sine of 45. And that gives us also a 1. So just j. Can I just get I lost my last brain cell. I feel you. That's how I felt about 10 minutes ago when my brain just like disappeared. I had to go find it somewhere inside my head. It'll be okay. So let me recap. We had a number in rectangular form. I changed it to polar form. I got the square root of it. And now this is where I am now. This is the first square root. The problem is I need another root. And so I do one thing. To get the second root, I keep the root the same. I'm trying to think, I probably could have organized this a little bit better. Let me think here. I regret organizing it the way that I did. Anyway, we have this 45. We need to add 360 to our original angle. So we say, take this 90 and add 360 to get our second root. So I'll organize this better in the second example. I'm sorry about this one. So the angle, the second root here, is going to be 90 plus 360, which is 450. You need to get the solution to that as well. Sorry, clearly I got lost here in my brain. Doesn't happen too often. When it does, it's bad. Okay, so we added 360 to the original angle. Do the same process again. So it's root 2. What is 450 divided by 2? Or sorry, multiplied by 1/2, same thing, 225. I really should have organized this better. Which is root 2 cosine 225. -1. And root 2 sine 225, -1j. Okay, so just give me a second. I'm going to reorganize how I have this on the page because I regret everything. Okay, let me see. It'll just take a second. I'm doing this for your benefit, hopefully. Okay. So let me recap because I got a little confused there just because I lost my train of thought. The whole point of the question is to find two answers. So looking back on this, we actually got two roots, whether you believe me or not. That's what we call the roots of this polar number or this complex number. The way we do it, we take our original question, we convert it into polar form. That's the first step. Then we just do the roots of it. We do that to the power of 2, sorry, power to a half, do our De Moivre's theorem here, and then convert it back to rectangular form. This answer here is in rectangular form. The second step, and the biggest step, the real important step, is that whatever angle we have to divide by 360, sorry, add 360, and get another angle, which we do the same thing to. Now, in the end, we have two roots. The number of roots you get out of this, the number of times you add 360, is equal to however many, whatever the type of root is. If it's a square root, you have two roots. If it's a cube root, you have 3 roots. If it's a power 4, you have 4 roots, and so on. Okay, so that was, sorry if I lost you all. I'll do another example, okay? Can I just confirm that everyone's still alive out there? Okay. I'll try to make this as clear as possible. I'm going to take it on myself to know that that was probably the worst I've ever explained that. But I'm going to blame it on coronavirus. I don't have coronavirus, but I'm going to blame it on everything that goes into my head when you're isolated for this long. Okay, let me try to summarize this. We want all the complex roots of this equation. This equation, we can see right here, has a power of 4. If it's got a power of 4, it means there's going to be 4 roots. We'll see that this means we need to add 360 3 times. Basically, we're going around and around this circle to try and find all the roots. I'll try to make it as clear as I can. First things first, this equation, x power 4 minus 16 equals 0, we need to solve for x. Because it's not given in a nice form. That's x power 4 equals 16, or x equals 16 to the power of 1 over 4. Now, we need this in polar form. What is this number in polar form? I'll try to write that again. For anyone who still has brain cells left.
It will be 16 plus 0j.
Yeah, or
And,
just
the rectangular, and yeah, it will be 16 0 theta.
So same thing, 16 0j, which is the same thing as 16 theta. If you want to sketch for that, it's the same as saying, okay, it's just 16 along the x-axis. Now, what we need to do is we need to get 4 roots of this. And believe it or not, it's actually a pretty simple process, even though I probably over-explained it before. You need 4 roots. 1, 2, 3, 4 roots.
4 roots mean 4 times. We need to have
We do
4
it 4
solutions.
times. We try to pull out 4 values from this number. So we say 16 angle 0. We want to get the 4th root of that. So I'll try to make this clear. That means we need to do 16 to the power of 1 over 4, and we need to do 4 times 0. So what's 16 to the power of 1 over 4? That's 2. Right? I'll try to match these things together so you know what I'm talking about. And then our angle. Well, what's 4 times 0? 0 times anything is still 0. I need to change that into rectangular form and I'll be done. It's just 2. If you want to know why it's 2, remember it's 2 cosine of 0 plus 2 sine of 0, j. This is 1, this is 0. Are you with me so far?
Yes.
Yes.
Okay. I've got 3 of you that keep me alive. Okay, second step. What do? We need 4 roots. Basically, we have one number. We need to extract 4 roots out of it. What we do is we keep adding 360 to see what we're going to get. So at this point, we want to add 360 to this angle to try and squeeze out one more root. That gives us angle 360. We are going to do this again and again. So this, once again, gives 16 power 1 over 4, but the angle this time is 4 times 360. 4 times 360 is obviously big. It's going to be very big. Sorry. I made a mistake. I made a big mistake. It's power
It
1
should
over
be
4.
1 over 4.
Yeah,
Yeah.
it's 1 over 4. Yeah. I didn't notice it before because it was divided by, it was by 0. We need to divide it by 4 because we don't want a big angle. That's the whole point. It'll actually never be over 360 when we do this process. That's 90.
Should be.
And think about this, you know, you don't need to use your calculator. You have 2 as your radius, and then you angle it up 60. 90.
It's 2J.
2J. Exactly. It's just 2 straight up. All right, I'll do the rest. 16. I add another 360, that's 720. You know, I can basically do the same process. I might as well write out all the work. You don't need to write this every single time.
Should be -2.
So divided by 4, 180. 180 is a full turn over that way. And so that should be -2, like you said. And hopefully you can start to see this pattern. It's not complicated, it's just new. Times 1080. It's 2, 2, 2, 2, 2 all the way down. And then 1080 divided by 4 is 270. You'll also maybe notice that the difference is the same every time. This was a jump of 90. This is a jump of 90. This is the jump of 90. So there's different ways to work this out, but I'm trying to not give you too much information all at once. It's already enough work as it is. Oops. I got a little bit excited with my deleting here. All right.
-2.
-2. J. Okay, so what this means is that we have roots that lie on the axes, but that's a story for another day, another course. Essentially what we need is we should have 4 roots. If you have more or less than 4, you're wrong. Because remember, in the very beginning, there's a 4 here. We should have 4 roots in total. Just like when you got square roots of a number, like, let me give you an aside here. This is the last thing I'll go through. If you had a square root of 4, it's plus or minus 2. You've got 2 roots out of that. If you have a cube root, you should have 3 roots. If you have a power 4, you should have 4 roots. It's just how this stuff works. Okay, so those are actually done in the videos, but how is that sitting?
It's fine. Star power.
For you.
Finally.
Maybe you're Superman, I don't know. So that's basically that. I do want to do one more question just because obviously you've got an assignment on Sunday and this could be part of it. In fact, I'll tell you that it is part of it. Sorry, I'm just reading Aisha's message. So it's okay if we write x to the power 4, 2 to the power 4, which is x equals 2 instead of 61 power 4. Sorry, I am not entirely sure what you're asking right here, Aisha.
This mean the 16 is equal to power 4. That means they get the answer from the first one. I think that's me.
Well, I see what you mean. We don't really want to solve the x fully because we don't really care about that x specifically. We actually need to keep the root because we need to convert it into polar and then use the root for an advantage. I guess what I'm trying to say is if you get rid of the exponent of 1/4, you can't actually go ahead and solve for all the rest of the roots with the angles in polar form. You know, like, if I understand correctly, if you were to solve this fully, then there's no way of you to get this power 4 when you have converted it into polar form, if that makes sense. Because again, we don't really care about x, it's just helping us get to our final roots. Okay, I'll just assume that that's okay. So I'll do a little bit more. Again, I've already fully covered this topic now. In fact, you're done all the topics. You'll notice that this is only page 27 or so of 32. The rest of the topics in the book are actually just extra practice, starting on page 29. So 29, 30, 31, 32, all those pages are extra practice for you. I won't cover them. Unless you ask me specifically, I can, of course, give you a hand. But I want to do a couple more questions. Let me see if I can find a interesting one. Let's see. I'm just going to go ahead and do E, since it is the longest one, and we'll be done for the day, okay? So this is E in practice. That'll be the last one I'll go through for you. First things first, we should notice that it has a 5 on top. You might see it somewhere written that that's our n value, which it is. It just means we're going to have 5 roots. And that also means we need to add 360 4 times. Just adding everything.
It will be 5 and 5j, -5. The same things. What we do in B.
I don't think so, because the way this works is for every root we have, it splits one circle into 5 pieces. So it can't possibly be on the axes.
Yeah, it's different.
It'll be different. If it's a root of 4, then we kind of get this nice pattern, but that's a special case. All right, you get this, -32. We can see that this is actually -32 to the power of 1/5. Now, right away, you should see that this is kind of a little bit different. We've got a negative to worry about. We'll convert it to polar form. Our polar form number from this is -32. So it's 32 angle 180. You know, you're taking this -32, it just looks like this. That's our sketch. Once I have that, we're really getting the root of it. And we can get all 5 roots now. We just do our regular process. Set it up, get the first root, add 360, get the second root, add 360, get another root, and so on and so on and so on. So we'll get 5 roots out of this. I'll do it the shortest way that I know how, okay? First root, 32 to the power of 1 over 5. That's 2. Maybe I don't want to skip any steps here because you might lose where the 360s come in. So this is our first group, our 1 over 5. That gives us 2, angle 36, because 180 divided by 5 is 36. We're going to convert that into rectangular form. Once you do that, hopefully you'll get 1.62 plus 1.18j. Sorry, I'll rewrite that. Following the exact same process as before. The 32 had the power of 1 over 5. The 180 was divided by 1 over 5, or divided by 5. Second step, we have 180 plus 360, which is 540. The first number is always the same. It's the angle that changes. 540 divided by 5 is 108. And if we change that to rectangular, again, I'm doing this quickly so that you have the work. 0.62 plus 1.90j. That's our second root. Third root. You should try this yourself if you know what the pattern is. You know, at least this is good practice for you.
It would be 180.
Yeah, well, we know that it's going to be the same difference between these, so you can kind of work it out whichever way you want. Wait, 180? I think 144. No. Yeah, 180. Thank you.
Welcome.
I don't know what I did on my notes here. I did something crazy. Is that what? Is this minus 2 cos 180 minus 2? And 0?
Yep.
All right, almost done. We're reaching the finish line here. Add another 360. It's 1260. I wouldn't give one this long on a test or assignment, by the way, just so you know. 252. 2 times cos 252. Negative 0.62. 2 times sine of 252. Minus 1.90j. Finally, the last one, 1260 plus 360, 1620. 2, 1620 divided by 5. Surely there must be a computer program that can do this for me. 2 times cosine of 324.
1.6.
2 times sine of 324. Minus 1.18j. Okay, we made it. Well, I made it. I don't know, some of you probably are watching Money Heist or something right now, but you know. That's our 5 roots. If you were to write those on the plane, you would see they split up evenly between 0 and 360. You might notice a pattern there. You should see a pattern. It's how these things work, but I'm not going to get into detailed into why there's a pattern because it's already 10:30. So all I'll ask, just as a summary point, you know, keep an eye on D2L. Know that I have my handwritten notes there if you need them. And please, please, please try the practice assignment under Dropbox, because if you have any issue with the Dropbox, I want to do it now, figure it out now, before Sunday when you need to use the Dropbox worth marks, right? I'll keep this open for a minute or so, but if that's it, you know, if you're all good, just feel free to go. If anyone has any questions, I'll stick around for them.